For 3 by 3 matrix, to do the ERO method, first we label the matrix, and then second thing is we form an augmented matrix form as you have learned before, which is 2 1 1 1 1 1 2 2 1, and then here is the identity matrix 1 0 0 0 1 0 0 0 1. For the first step is you need to obtain the leading diagonal, which is here. You need to obtain it into 1. So as you can see, the element in row 2 here at the first column is 1 already. So we use the interchanging row method. So step 1, you change row 1 into row 2 and row 2 into row 1. So you will get 1 1 1 0 1 0 2 1 1 1 0 0. And row 3 you didn't change anything, so you just copy back the solution. For the second step, step 2, as you can see, you want to obtain the element below the leading diagonal into 1. So the second row is equal to the original second row. Since here is 2, 2 minus 2 is 0, so we minus it with 2, row 1, the leading diagonals row, because row 1 is already 1. Same goes for the row 3. The new row 3 is equal to row 3 minus 2 row 1. That's how you obtain the formula. Then you calculate by using those two formulas for all elements in that particular row. At here, you didn't change anything at row 1, so you just copy back everything on row 1. So for the new row 2, what will happen is 0, negative 1, negative 1, 1, negative 2, 0. For the new row 3, you will get 0, 0, negative 1, 0, negative 2, 1. For step 3, you want to change the leading diagonal at the second column into 1. So as you can see here, the original element is negative 1. So from negative 1 2 become 1 is just you multiply it with negative. So the formula row 2, the new one, is negative the original one. Understand? So since you didn't change anything in row 1 and row 3, you just copy back everything first. Okay, now the new row 2 will be negative 0, 1, 1, negative 1, 2, 0. Then we go to step 4. Step 4 is for the element other than the leading diagonal at the second column. So as you can see, because since we want to obtain 0 for these two, it is already 0 at the third row, so you don't have to do anything. The main focus here is for the new row 1 is the original row 1. Since it is 1, 1 minus 1 is 0, so you just row 1 minus row 2, the leading diagonal row. 0, 1, 1, negative 1, 2, 0, 0, 0, negative 1, 0, negative 2, 1. And here everything will be 1, 1, 0, 0, 1, negative 1, and 0. Understand? Then we go to step 4. For step 4, you want to, step 5. For step 5, you want to obtain here the leading diagonal at the third column as 1. So it is easy since it is negative 1 already. So the new row 3 is equal to negative the original row 3. So what will happen? 1, 0, 0, 1, negative 1, 0, 0, 1, 1, negative 1, 2, 0. So at the new row 3, it will be 0, 0, 1, 0, 2, negative 1. For the final step, since you want to obtain the element above the leading diagonal into 0, but since the element in row 1 is already 0, so you don't have to do anything. Our focus here will be at the row 2 only. So the new row 2 is equal to the original row 2 minus it with the leading diagonal, which is row 3. Since 1 minus 1 is 0, you will get, okay, here you just copy back everything. For row 3 also, you just copy back everything. And then here it will be 0, 1, 0, negative 1, 0, 1. Then you have obtained the matrix here is an identity matrix. So automatically the matrix here is the inverse of A. As the conclusion, For the conclusion, you need to write A inverse is equal to 1, negative 1, 0, negative 1, 0, 1, and 0, 2, negative 1. Understand? To find the inverse of this matrix by using elimination row operation, so first we label the matrix as matrix B, and then we write it in the augmented matrix form: 2, negative 4, 3, 1, 2, negative 1, negative 2, negative 3, 1. 1, 0, 0, 0, 1, 0, and 0, 0, 1. Okay, so for the first step, you want to obtain here to 1. Since the element in row 2 is already 1, so we just change the row, interchanging row. 1, 2, negative 1, 0, 1, 0, 2, negative 4, 3, 1, 0, 0, negative 2, negative 3, 1, 0, 0, 1. Here is for the first step. Okay. For the second step, since you want to obtain the elements under the leading diagonal, you want to obtain it into 1. So for the row 2 is equal to the original row 2 minus 2 row 1. And for the row 3 is the original row 3 plus 2 row 1, because negative 2 plus 2 only you can get 0. So we proceed 1, 2, negative 1, 0, 1, 0. Now it will be 0, negative 8, 5, 1, negative 2, 0, 0, 1, negative 1, 0, 2, 1. For step 3, you want to obtain the element here into 1. Since it is negative 8, you divide by negative 8, you will get 1. So the new row 2 is equal to negative the original row 2 over 8. So the solution will be 1, 2, negative 1, 0, 1, 0, 0, 1, negative 1, 0, 2, 1, 0, 1, negative 5 over 8, negative 1 over 8, 1 over 4, and 0. For the step 4, you want to obtain the element here and here into 0. So what will you get is, for row 1, the new one is the original one minus 2 row 2, since 2 minus 2 is 0. And in the same time, for row 3, the new one is equal to row 3, the original one, minus row 2, since 1 minus 1 is 0. So you will get the solution. We copy back all the row 2 first. Understand? And then the new solution will be 1, 0, 1 over 4, 1 over 4, 1 over 2, 0. 0, 0, negative 3 over 8, 1 over 8, 7 over 4, 1. For step 5, you want to obtain the element here into 1. Okay, since one is equal to the negative 3 over 8 times negative 8 over 3. What is 1 here? 1 is the new row 3. Negative 3 over 8 is the original row 3. So meaning that the new row 3 is equal to negative 8 over 3 row 3, the original one. That's how you form the formula. Understand? So first, we just copy back everything in the row 1 and the row 2. 1, 0, 1 over 4, 1 over 4, 1 over 2, 0. 0, 1, negative 5 over 8, negative 1 over 8, 1 over 4, and 0. Here will be 0, 0, 1, negative 1 over 3, negative 14 over 3, and negative 8 over 3. And then for the step 6 is you want to obtain the element here into 1. So what will happen? The new row 1, since 1 over 4 minus 1 over 4 is 0, so the original row 1 minus 1 over 4 row 3. And then since negative 5 over 8 plus 5 over 8 is 0, so the new row 2 is the original row 2 plus 5 over 8 row 3. Understand? So we proceed with the solution. It will be, I just copy back first everything on row 3. Understand? And then here the first row is 1, 0, 0, 1 over 3, 5 over 3, 2 over 3. The second row 0, 1, 0, negative 1 over 3, negative 8 over 3, and negative 5 over 3. As the conclusion, B inverse is equal to 1 over 3, 5 over 3, 2 over 3. Negative 1 over 3, negative 8 over 3, negative 5 over 3, negative 1 over 3, negative 14 over 3, and negative 8 over. That's how you solve the 3 by 3 matrix for inverse by using elementary row operation.